let's go ahead and find all the second partial derivatives of our multivariable function f of xy. F of xy is x to the sixth y minus 2x cubed y squared. All the possibilities that we can have for our second partial derivatives are xy, yx, xx, and yy. There's no other possibilities that we can have. So those are all the ones that we can evaluate. And I'll predict the future. If we're doing everything right, these two should be equal. These have to be equal. Let's see. So f x y, that's first. fxy is treating y, finding the partial derivative with respect to x first and then y. So before we do that, let's actually go ahead and find the partial derivative with respect to x of xy. Of xy. This is treating y as a constant, so it's just going to be 6x to the fifth y minus 2y squared, y squared times 3x squared, which is just 6x squared y squared. Now, similarly, I'm going to do fy of xy, but not fxy yet. This is going to be useful for later when we do the the y integration first. So perhaps I shouldn't do this, but I'm doing this just because I want to do the partial derivative, the first partial derivatives first, and then go on to doing the second ones, because it's going to be useful for us later on anyway. So this is going to be treating x as a constant, so it's x to the sixth, that's the first term, and then minus, treating the same thing, x as a constant, so it's minus 2x cubed times 2y, which is 4x cubed y. That's pretty much it. Now let's continue on and let's find the partial derivative. Let's find f sub x y of xy. That is taking this with respect to y. That's going to be 6x to the fifth minus 6x squared times 2y, which is of course 12x squared y. So that's our first one. We want to find all of them. That's our first one. That satisfies that right there. And then let's move on to the second one. So fyx is going to be taking this and integrating with respect to x, which is going to be 0, or rather 6x to the fifth. It's with respect to x, not y, and then minus 4x cubed. Same mistake. It's with respect to x and not y. 4y 3x squared. So it's 12x squared y. That makes a little bit more sense, because I remember I promised you that we would have the same result for both of these. Indeed, they're equal. Yeah, I made some mistakes. I apologize for that with respect to x and with respect to y. It gets confusing sometimes. That should be a word of caution. Switch colors and let's go to the next one. So fxx is taking this guy and integrating with respect, or taking the partial derivative with respect to x. So treating y as a constant. So it's going to be 6y times 5x to the fourth minus 6y squared times 2x. That is 30x to the fourth y minus 12xy squared. That's fxx. Let's move forward to the final one. I actually like that color. fyy. That's taking this and integrating with respect, I keep saying integrating, find the partial derivative with respect to y, treating x as a constant. Now this is going to be 0. And then minus treating x as a constant, it's just 4x cubed, which ends up getting you to negative 4x cubed. I've had thoughts on scrapping this video because of the mistakes I've made, but again, those are natural, especially when you're first doing this. This is not my first time doing this, but I still made mistakes, so it is what it is. These are the 4 partial derivatives that you can find, I should say second partial derivatives that you can find of this multivariable function.